For me, my project is called a sitting post tractor, and it's like it's a application that an algorithm that uses an algorithm to detect the person the person is sitting like correctly or not, and it's about just using a camera and just taking a picture of people, just a picture of the computer user, and see if they are sit correctly or not. Let me briefly describe this project a little bit right now. And people right now we have a problem of people have while using computer, computer, and people have a difficult time to keep track, keep their back straight. Like they when using computer, they are not like they're not like noticing that themselves of leaning too much forward, and if that happens, their back tend to have injury when they're leaning too much forward and for too long, and it can be like getting like it can be in a injury that affecting people's back, and just like but people are just like not noticing themselves being leaning too much forward, like forward a lot. And most people have to spend plenty of times on seats. Like so, some people like have to like working in their using their computer, especially computer programmers like me and other people, and computer users are have to like spend a lot of times on computer, so they are not noticing themselves of leaning forward after a long time to use it. In our solutions, we have a real-time camera detection of position, and it is the camera that it is a camera that take pictures that that's sent by the AI, and if the person is not sitting correctly, the AI will know if they are not sitting correctly, and it uses a smart AI system which determines if the sitting seat position is good. It is about the AI is like it just sees people, and it will mark the points on the pictures. The AI is about taking pictures, and it just it's drawing it's drawing the points on our body. Like our body, we have heads, and we have hips, and we have like feet, and also we these are the position that we are using to determine if the person is sitting correctly or not, and it will give feedback on the sitting position. It is just like a feedback on it, and it will just like alarm the user if they like not sitting correctly. Next up is how it works, and I developed the program using Raspberry Pi. It is a computer, and it is it takes pictures on the Raspberry Pi. It uses a camera because to see the person, because Raspberry Pi is sometimes like not capable of doing like logic, like heavy tasks. So it will so the program is not like as good as it's supposed to. And the second thing is to analyze the frame in the video. The videos is actually the pictures taken by Raspberry Pi. For the analyzation we use TensorFlow Lite. It is a it's a deep learning AI system that can like like mark a person body parts. They it actually to mark a point, they actually return the coordinate of the person's of the points that they marked on the photo. So we use these points to calculate the angle of the body part in the leg. It's actually we use the coordinate of the points to calculate if the person is leaning forward or they are not like sitting correctly. And when determining the angles is less than a certain degrees, we consider bad positioning. It's just like when the person leans forward, the angle will change. So if it leans forward, and the angle will decrease. So after it's less than a certain degrees, so and it will consider it feedback, and it gives feedback on the calculated results. The feedback can be simple, okay, meaning that it will not warn you for doing that. It can also be having a bad posture, then it will send a message of you're not sitting correctly, and to fix the sitting posture. And the result because like as I mentioned before, Raspberry Pi is not like a perfect system. It's not a system that can handle heavy tasks. So it can often run into errors. And also TensorFlow is actually TensorFlow can also sometimes run into errors because like not all the points that are required to calculate the angle are marked. It's just like not marking on the image. And let me explain the process right now. At first, we use Pi camera. We use Pi camera. It is a camera used by Raspberry Pi to it's installed onto Raspberry Pi. And actually, for the camera part, it can be any camera, but I use Raspberry Pi for my testing. It is installed onto Raspberry Pi 3. It is like a model of it. So I just call it Raspberry Pi, and I use TensorFlow Lite. It is a algorithm to see if the person is sitting in bad posture, and the camera sends data to the TensorFlow Lite, and TensorFlow will see the person, and it will mark a point and return some data back to the Raspberry Pi. And Raspberry Pi will use the data to alarm the user. Like if the data is like we use like a triangle method to calculate the sitting posture. So if the data set is like giving like like numbers that they can be calculated onto a certain angle that's less than a certain amount. So when leaning forward, and it will alarm you for sitting bad, not correctly. Here's a demo. We can see on this image right now. Okay, you can see an image over here, and points are marked. There's like points marked on the each body parts. Like even though it is like this like TensorFlow is actually an algorithm that can mark a point. Like here's a picture of me sitting in front of a computer, and there's like green dots, or there's green dots. These are the dots that TensorFlow mark on my body, on the image. And for the red line, it's like I just like want to like demonstrate it to use. Actually, the red line in reality does not have any real purpose. So it's just like we use our shoulders over here, and here's our hips, and here's the knees, and it draws a line over here, and we basically calculate the angle on point 11. Like TensorFlow actually mark point on with numbers. For example, 5 is our left shoulder, and 7 is our left elbow, and 9 is our left hand. But if you switch to right, and it will become like even numbers, like 6 for the right shoulder, like 8 for the elbow, and 10 for the right hand. But it's not like seen on this image, so it is not marking it. And because when TensorFlow doesn't see a body part that's exists in the image, then it will just not mark it. And also this thing, because TensorFlow gives us the coordinate of the points located on the image. So when a point is marked on the image, then it can be there's an x-axis and y-axis, and like this. When x-axis like increases, like it goes to right and like that, and like we use the math equation, we use a math equation, I will later explain it, and it's basically like on the 5 thing, like it just like for the 0.5, it will return like a x value and y value, just based on this where is this dot placed on in this image. Like it can sometimes be like more left and sometimes more right, just like it's like based on how you place the camera, and it's just like it's just determining the coordinate, the angle of the person sitting. For example, this one, and also we also work. This camera also works on the right side. So even if I put it on the right, it will work on the same. And angles calculated with the hips, and it says 0.11 on the image over here. You just calculate. This is an image of it, and explain how it works. For the code, I use some like other libraries and some algorithms. The most important one would be TensorFlow. It is one that it could calculates the angle of the it's marked it's responsible for marking point on the image that it takes. High camera is basically taking pictures, and CV2 is the code library that is used to take the pictures. Because because the code doesn't come with a camera function, so I have to import it separately. Angle calculation is basically a math algorithm. I will later explain it. In a body map, a body map is just a picture that taken by the camera and marked by TensorFlow light. Here's the code that I wrote over here. The code is that here's my math equation over here. This part is I wrote this program using Python. So most likely many programmers knows that language, knows this language. So this one on this part it is the angle calculation. So here means angle calculation means that we input the x value and y values of the point that we are using, and also the x1 will be the and also x means x coordinate and y means y coordinate, and 1 means point like 0.1 and 0.2 and 0.3. So we have 6 values and we have 3 points that we are using. L over here means line. Line means we connect the dots. We just like using in math, we use square root of the equation over here. The difference between the x coordinates and squared plus the difference in the y values, we can square as well. Then it will be the. Then after that, we take square of it. Then we have the length of the line 1 to 2. And we have the same thing for 1 to 3 and 2 to 3 as well. And this one will be a try method, and this one will be an angle. We use this equation to calculate angle. It's mostly a cosine, and to use the length of the equation, and it's basically the calculation of the method. But the annoying part is the try method. Like I have a try method over here because like this equation contains a division over here. So in this part, the problem is when any of these two numbers are 0, then this whole number will become 0 since this is multiplication. And because we cannot divide by 0, so when I try to divide by 0, the program will crash. So I could try over here. So Python has a try method that allows the programmer to keep track if they are if the code is always working or not. And so if it doesn't work, if the code doesn't work, like because as I explained earlier, because Raspberry Pi is not a system that can handle like heavy stuffs, so it can sometimes run into like errors. Like TensorFlow is sometimes like if, for example, like if and a point of your body at the body is off screen, so and TensorFlow will not mark the mark the point. So if not mark the point, then we don't have a x value of that, and because this number will default to 0. So if any of these is 0, so the whole thing will be 0. So if it becomes 0, then we run the error. So I could try over here, and if any of this is 0, so then it will have a debugger message to like it's basically on user interface. it says it will give us an error, so it will have an error, and it will, and it also like for the actual code, for the actual code, it has a equals to 0.1, and down here we have the this description over here, like it's mostly basically this one down here, and this if statement is basically the calculation of the point. It just like hips one, like it just hip one is basically the hip one is about, I just name it hip. So hip ear one means left, one means it will be on the left, and two means on the right. So this 3 over here means 0.3. So it will be the shoulder. But at first I want to like use the ear, but I think shoulder was more accurate. So I changed to 3, so to make it more accurate. And 4 means that's on the right shoulder, and this is the hips, and one for hips, and one for knees. And we just input these numbers into here. So if it's less than 6 degrees, then it will warn the user, and the same goes warning over here. I also developed this into an app. So on the app version, then it will, then this that will change. I also modify the database to use the app. And if it's greater than 140 degrees, which means leaning backward too much, which will also like it's also bad. It's also bad to the user's back. So if it's more than 140, then it will also warn the user. And if we calculate 60 degrees, like on the right as well, just same thing on the right. And it just save the image on a CV2 camera to save the image. And for this part, it just there's some question over here, like